Introduction to regular expressions. This nugget is all about recognizing data. And so that's what we'll start by talking about, how to recognize what data is by looking at the format of the data. In Windows PowerShell, the way you do that is with a regular expression, or regex. And so we'll take a look at a simple regex, and then the -match operator that you use with regular expressions. Then we're going to spend the rest of the nugget diving into how regular expressions work, looking at repeating groups and wildcards, different sets of characters, whole character classes, grouping patterns, and we're going to wrap up with some really good examples and resources for working with regexes, including examples for some common data types that you'll have to work with. Finally, we'll look at the select string commandlet, which has some great capabilities when you use it with regular expressions. Computers and indeed our entire lives are filled with different types of data that we recognize based primarily on their format. For example, when I run ipconfig, there's a lot of data displayed here, and many of these things I recognize as IP addresses. Now, this particular one, 255.255.255.0, looks to me like it could be an IP address. In fact, it's a subnet mask, which I guess is type of IP address. But really when I'm looking at it, I'm looking for that format of 3 numbers, a period, 3 numbers, a period, 3 numbers, a period, and then 3 more numbers. In fact, our lives are really full of all kinds of different data that we recognize based on its format. For example, in the United States, you might recognize that as a phone number, a collection of 3 digits, a dash, 3 more digits, a dash, and then 4 more digits. International callers might recognize something like this, a plus and then 1 or 2 digits on front of the phone number there. Again, in the US, something like a series of 5 digits, or 5 digits followed by a dash and 4 more digits, might be recognized as a post office zip code. So there's all different types of data in our lives, and that extends to the computer world too. For example, we easily recognize 2 backslashes, a string of characters, a backslash, and another string of characters as a UNC path, or a Universal Naming Convention path. And that pattern might actually extend. This portion of it here might repeat. So we might have a folder and then even a file name afterwards. You might also recognize this type of data. We call that an email address, and we recognize that by having some string of characters, an @ sign, some string of characters, and then the ending, usually 3, maybe 2, maybe 4 characters, but all of them from some fairly small list of acceptable alternatives. Another type of data you might recognize is the old NT or NetBIOS style domain credential. Again, a string of characters, a backslash, and another string of characters. And we're not really expecting much in the way of punctuation in here. Usually it's just going to be letters and numbers, possibly an underscore now and again. What's important to note is that we're recognizing all of this data based entirely on its format. We don't know if this is a valid email address in the real world, and we don't know just by looking at it if this is a valid UNC in the real world. Similarly, if I punch out an IP address like you might recognize this as an IP address. It's got these groupings of digits and periods that we're accustomed to in the format of an IP address. But this isn't guaranteeing that this is a valid IP address on a particular network. We are just recognizing it as an IP address based on its format. Again, as far as the computer is concerned, this might be a valid IP address, at least as far as the format goes. It does have the correct format for an IP address. It's got the 3 digits, a period, up to 3 digits, a period, up to 3 digits, a period, and then up to 3 more digits. Now, once we do some validation or boundary checking against this, we realize that this particular value and this particular value are out of range for an IP address. But that doesn't stop the format itself from being correct. So that's really the difference between the format of data versus the validity of the data. Now, when a computer needs to recognize the format of a data, it uses a regex, or a regular expression. But all a regex does is validate the format of the data. It does not check the validity or the accuracy of the data. So what we're going to be looking at for regular expressions is a way to tell Windows PowerShell what certain types of data look like, the patterns that make up certain types of data. We're not going to be checking for the validity of that data, just the format being correct. Now, regular expressions aren't just used to match patterns. A pattern such as a series of characters, an @ sign, and then a series of characters representing an email address. Sometimes regular expressions are used just to check for literal characters. For example, Don, D-O-N, is a potential regular expression. If I compared it to several different strings, such as Don, Donna, let's just make up a word here, and then Chris, some of these would match the regular expression. This first one is obviously a match because the characters DON occur within the string. Regular expressions do something called floating. For example, this second one is also a match because DON occurs within the string. Just because there's a couple of extra characters doesn't bother it. Once it finds the match, PowerShell's happy with it. This also matches, again, because of that floating. There's the DON it's looking for. The fact that there's an extra character at the beginning and a couple of extra characters at the end don't make a difference. It just needs to find that match. This one does not match because it does not find the DON anywhere in the string. So that's a very simple, basic regular expression. Let's take a look at another one. Let's take a look at big. Obviously, BIG would be a match because the BIG is there. Bigger is a match because, well, there's that BIG. Even if it's a phrase like really big with a space in the middle, this is still a good regular expression match because there's the BIG that we're after. And the purpose of a regular expression is really twofold. The first is to say, yes, this string matches the regular expression. But the purpose is also to say, this is the portion of the string which matched the regular expression. And this is the portion of this string which matched the regular expression. So we're really looking for two different things. Is there a match, which is obviously going to be a true or false indication. And then we also want to look at, well, okay, if there was a match, what matches did you find? So let's take a look at what some of this looks like in Windows PowerShell. So let's get the shell open. We'll clear the screen to give us some room. Now, the way we use regular expressions inside PowerShell is the -match operator. You start by giving Windows PowerShell a string, then the -match operator, and then the regular expression that you want to check. This is a true match. Donna does match Don because the regular expression characters, DON, are found within the string there. We'll take that other one that we used and see that that also matches. If we give it a different string, which does not contain DON, then we get a false back. When we get a true, such as in there's a special variable called $matches, and we can look at that, and Windows PowerShell will show us what matched. And what's interesting is that regular expressions in Windows PowerShell by default aren't what's called greedy. In other words, as soon as they find a single match that matches the regular expression, they stop looking for more. So even though this regular expression actually contains the match a total of 5 times, only one match was actually noticed by Windows PowerShell. And the $matches tells us that. There is a way, and we'll look at it in just a little bit, to tell PowerShell to return as many matches as possible. So after it finds the first match, it'll keep looking to see if it can find more. And in that case, $matches would actually list all of the matches that Windows PowerShell found. So that's one form of a simple regular expression. Let's take a look at another. Does gigantic match big? No. Does bigger match big? Yes, it does. Does really big match big? Yes, it does. And what was the match? Well, big. And that seems kind of obvious in a simplistic regular expression like this, but once you start using more complex regexes, it's really useful to know what exactly PowerShell matched on when it tells you true, especially if you were expecting a false. Now, one thing to keep in mind is that Windows PowerShell is not case sensitive with these regular expressions. For example, Donna in uppercase match Don in lowercase is true. If you need it to be case sensitive, there's a slightly different operator to use. Donna CMatch lowercase Don is false because now it's a case sensitive match. If I go back and change Donna to lowercase, now it'll match because the case is being considered as part of the matching. Typically, though, you'll be using non-case sensitive, which is just the -match operator. Now, if you forget what some of these regular expression things are, no problem. Windows PowerShell is here to help. Just type help about underscore reg asterisk. And actually the whole thing is about underscore regular underscore expressions, but that's way too hard to remember, let alone type. Just typing this much will get you the about regular expressions topic. So the first thing we're going to talk about are wildcards. Period, which matches any single character. The asterisk, which matches 0 or more instances of the preceding character. And I kind of like to remember that it's 0 or more because the asterisk is, well, it's roughly round in shape, like a 0. And the question mark matches 0 or 1 instance of the preceding character. And I think of that as matching 0 or 1 because the question mark is more upright, like the number 1. So let's take a look at some of these. We'll take the string Donna and ask PowerShell to match that with DON period A. And that's true because DONNA matches DON period A. That second N, the fourth character, can really be anything. If I go back and change it to a 4, it'll still work. The other characters have to be a literal D, O, N, and A. If I change one of them, I won't get a match anymore. The period is only allowing that fourth character to be anything it wants to be. And it has to be there. For example, if I only have 4 characters, it's false. See, the DON4 matched DON period, but the regular expression was also looking for that A, and it didn't see it in the string. So next up, let's look at the asterisk. And here's kind of a common mistake. Donna match DON asterisk A. That'll be true, but maybe not for the reasons you think. Let's try changing this to a 4 here. And now it's false. See, the asterisk isn't standing in for a particular character. The asterisk says, I will accept a D, an O, 0 or more N's, and then an A. It didn't say anything about a 4. It worked the first time because, well, 2 N's is more than 0, and both of those stood in for the N star. In fact, I can put any number of N's in the middle, and I'll still get a match, because all of these N's are being accepted by N asterisk. See, the asterisk modifies the preceding character. If I take the N's out completely and just put like a couple 4s, it doesn't work. Even if I just put 1 4, it doesn't work. What will work is if I take that 4 out completely, because the N asterisk is looking for 0 or more. 0 is okay, so it said, well, here's the D, and that matches, and here's the O, and that matches. I'm looking for 0 or more N's, and I don't see any, but after that I want an A, and here's an A, so okay, that's all good. The question mark works kind of similar in that it modifies the preceding character. So if we take a string and ask it to match with DON question mark A, we get a false. See, this is saying 0 or 1 instance, and we had 2 characters. If I took one of the N's out, it would work fine, because now it meets the 0 or 1 criteria. In fact, if I took the N out completely, it still works, because it meets the 0 or 1 criteria. But as soon as I have more than one N in there, I'm no longer meeting the 0 or 1. I have 2, and so I get a false. And so those are some of the wildcards that you can use with Windows PowerShell so that you're not necessarily matching exact characters. For example, we might want to say, does this old style NetBIOS domain/user match and it does, because I happen to type the exact same number of periods as I had characters over here. So, you kind of have to be a little tricky. Obviously, that's not super useful because it would also match any series of characters that happen to be that length. Now, one question you might ask yourself is, what if you need to match an actual period, or an actual question mark, or an actual asterisk? For example, let's say we have a string containing MD for medical doctor, and we want to match it against M period D period. Well, that'll come back as true, but not because the periods were right. It's because these periods in the regex are matching any character. See, we could take that same string and put characters in here that we don't really want, and they'll still match because the periods in the regex are accepting any single character. So let's try doing that whole regular expression slightly differently. Let's take M period D period, which is our string, and throw in a match. And now, instead of using the period as a special character, we're going to use the regular expression escape character to escape the period. That takes away its special meaning, and it treats it as a literal period now. Then we'll put our D and another escaped period, and it's true. We need to make sure that bad data, or data that's not what we want, is kicked out. So we'll change those periods to numbers, and now it's false because Windows PowerShell is insisting on a literal period here. See, normally a period will stand in for any single character, but by escaping the periods, we've forced them to be literal periods. You can do the same thing for a question mark. For example, hello match hello is true, but only because this is saying give me 0 or 1 letter O. If I change this to help, well, it's still working because I had 0 O's, and then I happen to have another couple of characters at the end. So if we want to match on the literal question mark, we just have to put a backslash in front of it. Now if we take the question mark away, it's false, because it's looking for a literal question mark here because we escaped it. So those are the 3 wildcard characters in the regular expression syntax, and the escape character in the regular expression syntax. Okay, so far this is all kind of really limited value. I mean, for example, to really come up with a regular expression that will validate a domain \user, I've got to type DOMAIN \user. Okay, that's true. That's wonderful, but it's not really useful because it's only matching a fixed length, and it's not really keeping me from doing things like sticking numbers in here, right? The period stands for any character. Well, that's where character groups come in. Let's change this to say, in square brackets, we will accept anything in the range A through Z. Now, normally that would only accept 1 character, but we already know of a wildcard character that will say, give me 0 or more of those, and that's the asterisk. And then we'll have a backslash, but remember that the backslash is an escape character in regular expression, so it has special meaning. If we want to match on a literal backslash, we have to escape the backslash. We have to escape the escape character by typing 2 backslashes. And then we want A through Z, and we'll take 0 or more of those. So let's change this back to domain \user, and we get a match. Fantastic. Now let's stick a number in the middle here. And oh, it's still true. Well, that's not really what we wanted. And here's where that matches variable comes into play. Let's look at the matches. See, this portion of our string, domain \us, is what matched the regular expression. Windows PowerShell didn't care that there was a little bit extra on the end. We said we want 0 or more letters, which we've got, and then we want a literal backslash, which we've got, and 0 or more letters, which are right there. The fact that there's a little something extra at the end doesn't really matter. Well, here's how you can make it matter. It's called an anchor. I'm going to say that After those 0 or more letters, I want to see the end of the string. And that's what the $ character does. So now when I hit enter, it's false. Because PowerShell said, okay, well, there's my letters, and there's my backslash, and there's some letters, and now I'm expecting the end of the string, but there's more stuff here. So I'm going to reject that string. It doesn't count. It doesn't match the regular expression. Of course, we can mess that up on the other end too, right? If we go to the beginning here and stick in some digits, still false because this one on the end. So we'll change that back. And now it's true, even though we've got those numbers there, and we said all we want are letters. And again, by looking at the matches variable, we see that domain / user matched. Just because we had a couple of extra characters on the front of it didn't bother Windows PowerShell. So there's another way we can tell PowerShell to anchor this to the front of the string, and it's the caret. Now we get a false. Because we've told PowerShell at the beginning of the string, I want to see 0 or more letters. And it looked at the beginning of the string, saw numbers, and gave up right there. We still have one more problem with this. If I take out the 11, we should get a true. Now, let's take out the whole word domain. And we still get a true. That's because this wildcard says 0 or more. And, well, that's what we've got. We've got 0. So the other type of repeating thing we can add is a plus. So we're going to replace both of these asterisks with pluses. Now we get a false because plus says 1 or more. Now in order to get this to match, we've got to stick a domain name in here. And so it's true. At the beginning of the string, I want to see letters, and I'll take 1 or more of those. Then I want to see a literal backslash. Then I want to see more letters, and I'll take 1 or more of them, and then I want to see the end of the string. So if we go in here and stick in any character that's not a letter, for example, we'll stick in a period here, kicks it right out. Excellent. If we stick in some punctuation here, kicks it out. Well, maybe we don't want to do that. After all, an underscore and really numbers are legal characters in a domain credential like that, so maybe we need to extend this character class. We've got a couple of ways to do that. We don't have to specify a range. We could say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and we're back to kindergarten. In other words, we could provide a list of every character that we consider valid for that particular position. And we'll allow the underscore. Now it's true. Typing all that, little bit of a bummer. So let's go back to using a range like A to Z and stick in a 0 to 9 here and an underscore. Now it's true. And we can go ahead and stick numbers in here too. For example, we'll call this domain 5. So PowerShell is reading this as a range. It's reading this as a range because they've got that dash in there. This is just being read as a literal character, so it winds up being an acceptable choice. Domain, we'll say my domain 5, and that still works. So the next thing we need to do is think about limiting the number of matches. Right now we're saying 1 or more, but we're not putting an upper limit on it. In Windows, this really wouldn't ever be longer than 16 characters. So let's try and see what happens if we stick more than 16 characters in there. My very good Windows domain. It's still true, even though that's not really valid data. So we need to modify our regular expression. Instead of saying plus, which is 1 or more, let's, in curly braces, give PowerShell a range. We want at least 1 character and no more than 16. Now it kicked it out. If we back this down to just domain, we see that it's true because now it fits within that 1 to 16 limit. You've got a few ways you can use these curly brace limits. If you just put a single number, it means I just want 1 character. We have more than that, so it's false. If you say 1 comma, it means I want at least 1, but I'll take as many as you want to give me. And so that's true with this string now. If you use 1, a comma, and a 16, you're giving it a lower limit of 1 and an upper limit of 16. If, for example, you know all of your usernames are at least 6 characters and no more than 16, you can specify that. this string is false because the user is not at least 6 characters. If I make it at least 6 characters, then the regular expression finally reads true. So you've got a lot of flexibility to sort of design the data for however you want. Let's take a look at a different piece of data, an IP address. What's the pattern for an IP address? Well, we know at the beginning of the string, we want to see 0, 1, 2, 3, 4. Well, actually, we can use a range instead of typing them all out. We want to see a number from 0 to 9. We want to see at least one of those numbers, and we'll accept up to 3. Then we want to see a literal period, and then we want to see 0 to 9 again. And again, we'll take 1 to 3 digits. And then we want to see another period, and then 0 to 9, 1 to 3 times, one last period, and then 0 to 9, 1 to 3 times. And then we should see the end of the string. Great, that's a match. It's really important that we test bad data too. Let's stick a couple of extra numbers there. Now it's false because there were too many digits in that last octet. Let's try sticking one in the middle to see if we can fool it. Nope, too many digits in that second octet, so it kicked it out. We can change it to just 524, which we know is not valid data, but it has the format of an IP address. In other words, it matches our regular expression. There's no way to use a regular expression to do range checking, in other words. We can do a slightly better job with that regular expression because PowerShell doesn't restrict us to just using ranges of characters in square brackets. It actually predefines some character classes. For example, let's pull up that last regular expression, and instead of specifying 0 to 9, we'll do \d. That says I want any digit. I don't actually need to specify what the digits are in a range. I can just say \d, and we'll replace all of these. So that's still true. And if we come in here and stick a letter in here somewhere, it's false because the \d says only accept digits. Now, what's interesting about these character classes is that lowercase means one thing and uppercase means the opposite. So by changing these to uppercase D's in the regular expression, I'm telling it I only want to see non-digits, which means the only thing that'll work now is something like A, B, C, D, E, F, G, H, I, J. So another character class you've got is \w, and that stands for any alphanumeric character, not whitespace. For example, when we've got that domain credential, domain \user, instead of specifying a range of all the possible characters we might allow, we're just going to say at the beginning of the string, I want to see \w one or more times, and then a literal backslash, and then \w one or more times, and then the end of the string. It's a little more simplistic of a regular expression because I don't have to specify all the possible letters and numbers and punctuation that I'm going to allow. The minute I stick a space in the middle here, it breaks it because whitespace does not count as a character class. Underscore does count as an alphanumeric character. And again, the opposite of this is uppercase W. Well, this is now false. In fact, about the only thing it'll accept now is whitespace. Whitespace being a non-alphanumeric character. Now there is a character class that explicitly accepts whitespace, and that's the S character, not T. So that matches, and if we say uppercase S, we want anything but whitespace. So what is whitespace? Well, basically a whitespace is the space character, the tab character, or the carriage return. So now that we've said we want anything except whitespace, we can go put letters and numbers back in, and they'll still work. And if we stick some extra spaces at the end of the string, will it care? Yes, it will, because we said we want to see non-space, and then a backslash, and then non-space, and then we want the end of the string to occur. So because there was extra stuff after the last match, no match. So that's kind of an easier way of specifying these types of characters that you might want to specifically match on, rather than having to build an entire set of them inside of square brackets. Now, one type of data we haven't tackled yet is the UNC path, which looks something like //server/folder. Well, let's just start with that. So a good regular expression for this might be a literal backslash, another literal backslash, alphanumeric characters, I'll take one or more, another literal backslash, and then alphanumeric characters, I'll take one or more. And that's true. So let's try and make this wrong now to see if it kicks out. For example, this is not a valid regular expression, having extra characters on the front, and it's accepting it. And that's because I need to put this caret in here to anchor it to the beginning of the string. So now it will not accept any characters before the double backslashes. Great. So what if we just put a bunch of spaces out here? Well, that's still true, because we need to anchor this to the end. Now it's false. Okay, great. So if I delete all these spaces and it just sees alphanumeric characters at the end of the string, then we're good to go. The problem is, this is also a valid UNC. And it gets kicked out because we wanted it to go at the end of the string. Well, here's where you can create a grouped mini expression. Basically, I'm saying that the slash and then series of characters might repeat multiple times. So we're going to put the literal backslash and then the alphanumeric characters, one or more of them, inside parentheses. And we'll say, I will accept one or more of those units. I will accept one or more groupings of literal backslashes and one or more alphanumeric characters. And then I want to see the end of the string. So let's just start, see if this will take a bunch of folders from us. It does. Now if we stick a bunch of spaces at the end, it kicks it out. And we can put as many of those folders and things as we want to. We can type /file/folder/file as often as we want to, and it'll still work because it's accepting repeating groups of that particular regex. Now, what happens if we put .txt on the end? Unfortunately, a dot does not count as an alphanumeric character. In fact, there's probably a lot of characters that are legal in a file name that aren't counted as alphanumeric characters. So what we might want to do in here is instead create a group of acceptable character classes. We'll take alphanumerics, a literal period, and let's say that's all we're going to accept. Well, now that matches, and if we throw an extra space in here, well, that regular expression is not allowing file names with spaces. So if that's your goal, is to make sure that you can validate that data, then that's the regular expression that will do it for you. And you can see that developing a regular expression to accept or validate specific formats is kind of a really recursive process. You have to play with it a little. You have to make sure you're giving it good data and that it's matching, but trying some bad data too. And if it matches correctly on your bad data, then tweaking the regular expression a little bit. You can see that our original regular expression is quite a bit different from the one we finally came up with, but that's because we refined it gradually over time. Now I want to share a couple of extra resources that you can use with regular expressions. Both of these are on the internet. One is www.regexlib.com. This is sort of an open repository for regular expressions. Folks come in here and they share the regular expressions that they've made for various purposes. For example, if we wanted a postal code regular expression, we could just type postal code into the search and then get a list of different regular expressions. This one will match 5-digit US zip codes, 5-digit US zip plus 4, and 6-digit or 6 alphanumeric Canadian postal codes. This next one is just Indian style PIN codes. The next one will accept a variety of different things, including Canadian. So you've got a lot of different choices and things you can find here. This is a great way of just copying the expression, bringing it into Windows PowerShell, and saving yourself some time. If you do wind up developing your own regular expressions from scratch, there's a little tool called regexbuddy.com. Now this is a commercial tool. It is something you have to buy. It's $40, and it's actually a graphical user interface. So if you're building incredibly complicated regular expressions, this will help do it for you. You can also paste an existing regular expression into the tool, and it will break it down and sort of tell you exactly how it's going through and analyzing each bit of it to match or not match. And you've got a great little test tab that you can use to test various strings to see if they match or don't match, and a little debug tab that'll help you figure out exactly where your regular expression is going wrong and that type of stuff. So that's a really useful tool to have. Now let's take a look at one of the more complicated things that you might need to match with a regular expression, and that's an email address. So let's take a typical email address like don@nuggetlab.com, which is my domain name, and stick it up against a match. Now pay attention to how I walk through the creation of this. I know that the beginning of this regular expression is going to be strings. So right at the beginning of it, and I'm going to make sure to anchor it to the beginning, I want alphanumeric characters. And I want at least one, and possibly more. In fact, let's say for my domain, I know that that username is never going to be longer than 25 characters, and it's never going to be less than 2. So I'll say alphanumeric characters, at least 2, and no more than 25. Then I'm going to have an @ sign. And then for my company, I might match literally on Nugget Lab, literal period, com. That way, if I'm writing a script and it's trying to accept email addresses and somebody accidentally types nuggetlabs.com, they made a little typo there, it'll kick it out, and I won't try and use that bad data. If you wanted to make it a little bit more generic, you might say, I'll accept alphanumeric characters. I want at least 2 of them in the domain name, and maybe I'll take up to 30. So that still matches. It's a little bit less specific. And you can kind of start to see how an email address regular expression is very difficult. This one obviously will only work with .com email addresses. If you wanted, you could have it work with .org email addresses, or maybe you'll have it work with any 3-character top-level domain. So it'll work with com, it would work with edu, it would work with org. But unfortunately, if you said .co.uk, it would still work. That's because we weren't anchoring to the end of the regular expression. And now it kicks it out because it doesn't like that extra dot and then the letters. So creating the perfect regular expression really for email addresses requires you to get a little bit specific. Narrow it down to just your company's naming standards, for example. And again, try online tools like regexlib or tools like regexbuddy to find a regular expression that someone else has done as a starting point, and then use PowerShell or your tools to really refine it and debug it to get it to work exactly like you need it to work for your specific application. Now the last thing we'll be covering is the commandlet select string. So let's take a look at him. Select string. This identifies patterns in strings, and in a way you can think of it as kind of a big brother of the -match operator we've been using, but this usage of it here where you provide a pattern, and that would be your regular expression, and then provide a path is really intriguing. Let me show you how this works. A couple of other things I want to point out while we're here that we won't be looking at specifically is simple match. And what that does is it means pattern is not read as a regular expression. It's just read as a literal string that you want to match. And that can certainly be useful sometimes. And we'll look at an example of that. And case sensitive. By default, it is case insensitive. So let me kind of give you the setup here. On my computer, I've created a folder called regex, and I've created 2 files, just text files. And in their text, they contain IP addresses, such as 192.168.64.23. Just going to bring this down to the bottom of the screen so we can kind of remember what that is. And I've got 2 files with IP addresses. Now, these might also be IIS log files, they might be SQL log files, they might be exports from a database, any kind of text data really. We're going to focus on these because they have IP addresses in them, and that's a particular type of pattern I want to match. So here's the first use, select string. The pattern I want to match is 192.164 168 rather, .64.23. And I want to make this a simple match, not a regular expression, in other words. And I want to do the match in that file, c regex file1.txt. This is going to scan through the entire file and look for this match, and it's going to output every line of the file where that match was found. So you can imagine maybe scanning through a much larger file to find out which lines contained a particular IP address you were interested in. So when I hit enter, I find that it was contained on 2 lines, lines 1 and 4 of this file. What's really cool though is that this path can accept wildcards. So go to that folder and get every text file, and it'll show me both files contained that IP address on lines 1 and 4. Now maybe I'm not really interested in the specific lines. Maybe I've got hundreds of files and I just want to pick out the ones that contain that particular string. No problem. -list. Now instead of matching every single line in every file, it'll just show me the files where that string exists at least one time. Now let's make it a little bit more complicated by taking out the simple match and turning this into a regular expression. And instead of giving it a literal regular expression, or a little set of characters, we're going to turn these into literal periods. Show me everything that has an IP address 192.168.64. Any digits from 1 to 3. Okay, both of those files contain that. Let's take off the list parameter now and see all of the matches. Very cool. So it's actually matching different last octets, because I said for this last octet I just want 1 to 3 digits. Now, another thing we can do to modify this is say only show me ones where the IP address occurs at the end of the string. And this limits my results, so I only see the ones where the IP address is at the end of the string within the text file. And if we go back to my text file, you can see that every other line actually did end in an IP address. So this really enables you to reuse your regular expression knowledge in a lot of different ways, to batch process text files, to locate particular strings within a bunch of files, to find just a particular series of characters or strings across a bunch of files, all sorts of flexibility. This nugget was all about recognizing data based on its format. We started by talking about different formats that data can take, and we looked at a simple regular expression. The key to all of this is Windows PowerShell's -match operator. And then we looked at a lot of different ways that regular expressions can be built, using repeating sets and wildcards, character sets, character classes, and even groups of patterns. We looked at some examples for common regular expressions that validate certain types of data, and we looked at some additional resources that you have available if you need to work with regular expressions. Finally, we looked at the select string commandlet, which has some really great capabilities for looking in text files and grabbing information based on a regular expression that you specify. I hope this has been informative for you, and I'd like to thank you for viewing.